Welcome to Viking Tech Talks. I'm Jim Lake. I'm here with Shaun Kramer. In this edition, we're going to be talking about residential sprinklers. So I thought before we started into the frequently asked questions, what we'd do is we'd kind of explore a little bit of the difference between a residential sprinkler and a standard spray sprinkler. And we'll certainly, some of these questions that we have, explore that a little bit further. But the big difference, Shaun, between a residential sprinkler and a standard spray pendant or upright sprinkler is basically the spray pattern, right? I mean, a lot of the major difference. There's also speed, of course, and the way it's listed, what it's listed to, UL 1626 as opposed to UL 199 and all the criteria there. But if we take a look first at a standard spray pendant sprinkler, you see on the screen here that basically it's got a very conical shape spray pattern, and it's designed to protect those spaces, you know, that floor area directly below it, whatever's burning directly below it.
Right.
But if you move along to the principal difference here, we change over to a residential sprinkler, we see a much higher spray pattern, a much higher, why do we have such a high spray pattern like that? What are we trying to achieve there?
Well, we're trying to keep it cooler up at the ceiling and trying to keep the temperatures cooler for tenability to be able to escape in the event of a fire.
Right.
So a residential sprinkler is geared more towards life safety, where even though your standard spray sprinkler is protecting lives as well, it's more geared towards property protection than a residential sprinkler where we're just focused on life safety.
Okay, so with the standard spray pendant, we're really focused on what's below. Is there a requirement then for when we're getting a listing for under UL 1626? Is there a requirement for how high up the wall that needs to, or down from the ceiling, that spray pattern needs to actually hit the wall?
Yeah, with residential sprinklers, it's going to be 28 inches down from the ceiling, regardless of what the coverage area is for the sprinkler.
Okay.
So once you move out into those 20 by 20 spray patterns for some of the larger pendants and the larger coverage areas, you still have to be able to wet the wall on the side of the room 28 inches down from the ceiling with a residential, regardless of what the spray pattern is.
Right, and that's based on the fact that pretty much in a residential occupancy, your fuel load is not necessarily directly below the sprinkler like it might be in a standard kind of a light hazard occupancy, but it's mostly out there on the perimeter. That's where you put furniture in a lot of residential kind of arrangements. So
Exactly.
So life safety approach and a higher spray pattern, a higher wall wetting characteristic on the spray patterns is what differentiates the residential sprinkler from the standard spray. All right, let's get into the questions here. First of all, Shaun, the first question is that this individual is protecting a room that has a dimension of about 13.5 feet by 25 feet or a little bit more. Does Viking even offer a sprinkler that can cover this kind of area?
Yeah, we offer a sidewall sprinkler, our VK460 as shown behind us, that has a coverage area of up to 14 by 26 feet. So when you're looking at a pendant sprinkler, the maximum coverage area you can have is 20 feet by 20 feet.
Sure.
Because you're right in the middle of the coverage area. But with sidewall sprinklers, as long as you don't exceed that 400 maximum square feet coverage area of the sprinkler, you can take the width and the throw and adjust them as needed to get a listing for not necessarily both distances in the same direction.
Okay.
So with this one, it has a 14 by 26. It would be able to protect that area. There's also many other listings for the VK460 as well, and it has very low flows and pressures for all its different coverage areas.
So this can this can flow 26 feet. This can spray 26 feet out. Let's take a look. Let's go into the. Oh, we're already there. We're going to go into the flow lab here. I'm going to get out of the way for a second. Look at how far away this thing can flow. Let's run that again, Taylor. There it is again. So this is actually flowing out 26 feet. We're not getting wet at all, but it's flowing out about 26 feet from the wall. Is that right, Shaun?
Yep, that's exactly what it's doing there.
That's a lot of area to cover on for a sprinkler, but the answer to the question, the answer to the first one is yes. It's the VK460, and it can cover this 13.5 by 25 foot area. All right, so next question then. Let's come out of the flow lab and we'll dry off a little bit. And we're going to get into the second question. I'm laying out a design for the residential project, for a residential project that is being designed in accordance with NFPA 13 now. So just remember, just because you're using residential sprinklers doesn't eliminate NFPA 13. You can certainly design within that. Can I use the flows, though, the flows and pressures shown on the data sheet for the approval charts? Can I use those as opposed to NFPA 13? Or which, I guess the question is, which governs in this case?
Well, when we're looking at the approval charts for a residential sprinkler on our technical data sheets, what we show is a density of 0.005 gallons per minute per square foot.
Right.
So that's applicable to a 13D, 13R application. Once we get into 13, now we have to compare the two. So 13, you have your 0.1 density, and then on the approval charts, we have the 0.05 density. However, when we look at it, we got to use the more stringent of the two. And you might think to yourself, well, 0.1 is always going to be more stringent than 0.05.
Sure.
But what we have to really look at is, for example, let's say we have a 18-foot by 18-foot coverage area. You go to the approval chart, and as long as one direction's 18 feet with a pendant sprinkler, you have to go up to the 18 by 18 on the approval chart.
Sure.
Now, when you look at it to compare with the 0.1 density, let's say in one direction we're covering 13 feet, and in the other direction we're covering 17 feet 6 inches. With the 0.1 density, what you would do is you would multiply the 13 by the 17.5, then multiply it by 0.1 to get your flow.
To get your flows, sure.
And then when you go back to the approval chart, it's still based on a 0.05, but you have to go up to the 18 by 18 in that example and take the flow there.
Okay.
So whichever flow is more stringent, you're going to apply in this situation.
Okay.
Now, most of the time it is going to be the 0.1 density, but there are some odd-shaped areas out there where I have seen it where it's actually the approval chart is going to be more demanding than using the 0.1 density at the actual coverage area.
Okay, so this would only apply if we were using a 13, if we were actually designing in accordance with 13. So 13R wouldn't have anything that would require that comparison.
Yeah, you can use the approval chart with the 0.05 density if it's 13R or 13D.
Okay. All right, great. All right, so next question then. Shaun, why does Viking offer so many different K factors for residential sprinklers?
Well, we offer a wide variety of different K factors because what we just discussed in the previous question, where you have your 13D, your 13R, and your 13 applications, where you could be looking at a 0.05 density or a 0.1 density. So you start with the smaller K factors, the 3.0, the 4.0 K factors. That's more geared towards your 13D applications, 13R applications. Once we start to get into the larger K factors, our 5.8s and so on, now we're starting to get into the NFPA 13 applications where you could require that 0.1 density for that type of situation. So having this large variety of different K factors allows you to be able to take advantage of your different flow requirements based upon the standard that's being applied.
Okay. So everything changes a little bit as we go from K factor to K factor, but still it's 1626 that you're being listed as a residential sprinkler. Okay.
That's correct, yep.
Let's ask the next question. This one comes up quite often, whether we're teaching seminars or discussions regarding what is a residential sprinkler and a quick response sprinkler. So sometimes people get the terminology a little bit off, or they refer to a residential as a quick response resident. So let's look at the question: is there such a sprinkler as a quick response residential sprinkler? Let's just explore this terminology of quick response and fast response for a sec.
Yeah, sometimes there can be confusion with that because NFPA defines a quick response sprinkler as a sprinkler with a fast response element that's listed or approved as quick response.
That's just a spray sprinkler though, right?
That's correct.
It's a spray sprinkler.
That's your standard spray sprinkler with a fast response element. that goes through your commercial testing of UL 199 and has to pass certain requirements in order to get that quick response listing.
Sure.
Now, where the confusion comes in is if you look at a residential sprinkler, it has a fast response element in it.
Right.
So all quick response sprinklers have a fast response element, but they're tested to UL 1626, which for the residential standard, there's no such thing as a quick response sprinkler. So even though they have a fast response element in them, there's no term as quick response for a residential sprinkler. So that's a commercial term as defined in NFPA 13 and tested as per UL 199 in this case, using UL as the example for the testing standard.
So if I'm getting this right, the fast response terminology then refers to the element as opposed to quick response, which refers to a type of sprinkler. Is that clear? Is that right?
That's absolutely correct. All quick response sprinklers will have a fast response element in them. However, not all fast response elements are quick response sprinklers.
Got it. All right. Okay, next question. Is it possible to use an intermediate temperature rated residential sprinkler in an area that may not exceed an ambient temperature of 100 degrees? So why would you choose something like that? Why would you choose something of the intermediate temperature when you know you're not going to, or you never anticipate going over 100 degrees Fahrenheit in the space? Why would you even choose one?
Well, first off, NFPA, whether it's NFPA 13D, NFPA 13R, or NFPA 13, allows for the use of ordinary or intermediate temperatures throughout a building.
Sure.
Once we get into the higher temperatures, now you have to have a specific reason to go up to those higher temperatures, but you don't have to with ordinary or intermediate. So if you ever have a situation where you could possibly exceed 100 degrees ambient temperature, it's just a better practice to go with an intermediate temperature rated sprinkler because then you don't have to worry about it.
Right.
A couple examples where you could possibly see that would be down south in an apartment building where you have an unoccupied apartment and you don't have necessarily conditioned space throughout the summer. It could possibly exceed 100 degrees in that type of environment. Even up here in Michigan, just last week, for example, we had 90, 93, 95 degree days going on here up north. So if you think about an unconditioned apartment that doesn't have your AC on because, you know, nobody's in the apartment at the time,
Sure.
it could easily exceed 100 degrees as well. So that's one instance, anytime you could see that. Another good example, and one that we get some calls on, are hotels when they're turning up the temperatures to take care of bed bugs. I mean, I know that's something you never want to think about when
Yeah,
you
you don't
think
wanna
about
think
going to a
about that,
hotel, but
yeah.
it does happen. And what they do is they'll increase the temperature in the rooms up to 130 degrees, up to 140 degrees.
Sure.
And a lot of the times what will be installed will be an ordinary temperature rated sprinkler because in that situation you think it's a conditioned space, you don't have to worry about exceeding 100 degrees. Now when this happens and somebody comes in and they have to turn up the temperature, it tends to be an issue because you have those ordinary temperature sprinklers that can exceed the 100 degrees. So just in that application, by installing the intermediate temperature sprinklers, you would be able to take care of that situation and have no concern about the 130 degrees that they might be raising the temperature to in that situation.
Okay. All righty. I'm working on an NFPA 13D project now, this questioner asks, and the construction is 2x4 walls. The customer wants a flat plate concealed sidewall sprinkler installed. Is this even an option that Viking offers?
Yeah, as you can see playing behind us in the animation here, what we have is our VK480 sidewall sprinkler. It's a 4.0 K factor, and it's designed to fit in a 2x4 wall. So most sidewall sprinklers would not be able to fit in that small of a wall due to their design. So we launched the VK480 with a 4.0 K factor, which would work great for this application in a 13D installation. We also offer our VK490, which is a 5.8 K factor. So if you had 2x4 construction and you wanted to install residential in a 13 application, where you're looking at that 0.1 density, we also have an offering for that to be able to fit in the 2x4 construction. So both the VK480 at a 4.0 K factor and the VK490 at a 5.8 K factor would allow you for that type of installation in that environment.
All right, so we're watching the whole thing go installed into a 2x4 constructed wall, cutting it out, finishing it off. Look at that. That's a beautiful thing.
And as you'll see, once the cover plate's put on, you have your flat plate concealed sidewall, and you can get them custom color painted, whatever you would want for the home that it's going to be installed in.
For the decor. Great. Okay, we're going to move on then to question number 7. This person needs to protect a hotel room that is 22 feet in length after the bathroom and entryway. Says he would need to use 2 pendant sprinklers for each room. But is it possible, is there a possible option to protect 15.5 by 22 foot area with 1 sprinkler? Kind of goes back to a previous question we had, but what can we cover here?
Yeah, it's a different coverage area, and it actually would be covered by the 460 as well, with one of its different options other than the 14 by 26 to be able to cover this area. And the question, what they're asking with the pendants is, yeah, they would need 2 because 20 by 20 is the maximum coverage area you can get for your 400 square feet. So you're never able to exceed that with a pendant sprinkler. However, with the sidewall, as I had explained earlier, you're able to manipulate the width and the throw to be able to get different coverage areas for the width and the throw area there. So we would have a sidewall sprinkler that's available for that. But I want to go back to the start of this person's question here with the entryway in the bathroom. This brings us back to our question about the K factors and why we have so many K factors. In this example, if you had a hotel and you had to have a sprinkler in the entryway and a sprinkler in the bathroom, and then you have the sidewall protecting the bulk of the room, well, that sidewall is going to drive your calculations and your flow and your required pressure. So in the entryway in the bathroom, if you went with, say, a 3.0 K factor pendant sprinkler, because you're not covering a large area, it helps you to reduce the overall flow of your calculations based upon the pressure that's going to be required out of that sidewall that's protecting a much larger area. So that's another reason why we offer so many different K factors, as you can utilize the different sizes to be able to get the best hydraulic calculations you can for your system.
Great. Next question then. I'm protecting a living room in this case that has a sloped ceiling, but when looking at our technical data sheets, there is not any mention with regard to slope ceiling listings for residential sprinklers. Can they be installed on slope ceilings?
Yeah, that's a great question. In the past, all us manufacturers had slope ceiling listings for our residential sprinklers. And then it started in 2010 and continued on through 2013 editions, where we stopped having the listings on our data pages, and it was actually incorporated right into the standards. So if you go into NFPA 13D, NFPA 13R, and 13D it's going to be in Chapter 10, and 13R is going to be in Chapter 7, and even in NFPA 13, if you go into the standards, you'll see where it gives you design criteria based upon slope ceilings. So no longer is it a listing requirement. You have up to an 8 by 12 slope where you're able to install it as per the standard on a slope ceiling without requiring a listing for that situation. So if you look at our older technical data sheets, you'll see some approval charts with listing criteria for slope ceilings, but if you look at our current data sheets, you won't see that anymore because now it's part of the standard.
So let's talk a little bit about slope ceilings, and why are slope ceilings, as we get steeper, because the next question kind of goes there too. What's the concern with a sloped ceiling, getting too steep? What effect does that have? Why do we pay such close attention to it?
Well, when you look at the way that the heat's gonna travel up, you have to travel up along the slope. So your sprinkler is gonna be at the high point of the slope, discharging downward along the slope because the heat's gonna collect at the top,
Sure.
activate the sprinkler, and then you wanna make sure, as per the standard, that you have your deflector aligned parallel with the slope of the ceiling as well
Okay,
for
so-
the spray pattern to spray down and protect the floor area.
All right, so we're concerned, number one, about the heat plume and the activation of the sprinkler.
Correct.
The second thing we're concerned about is making sure that the spray pattern isn't obstructed by actually hitting the ceiling before it gets down to the fire ceiling.
Yes, exactly,
Okay.
yep.
All right, so that being said, next question is, what if the slope of my ceiling is greater than 8 and 12? What do I do now?
Yeah, that's a good question because even when there are listings for residential sprinklers, currently there's no residential sprinkler that's listed for greater than an 8 by 12 slope ceiling. So in this situation, it comes up to the authority having jurisdiction to make a determination as to how they would accept this to be installed beyond the listing of the sprinkler and beyond the standard. And this is actually spelled out in the standard saying that it is up to the authority having jurisdiction as to what the requirements would be. Now, a portion in the annex of this section, as well as industry practice in the past, has typically been that in this situation you would calculate more sprinklers. So for example, if you had a 13D design where you typically are calculating 2 sprinklers, a lot of HJs would have you bump up to 3 sprinklers for that calculation, or 4 for a 13R, you would go up to 5. Some HJs in certain situations would have you increase the pressure.
Okay.
So you're increasing the flow maybe up to the next coverage area to be able to account for this. But at the end of the day, it's up to the authority having jurisdiction to make that determination as to how you would protect it because it's outside of the listings of any residential sprinklers.
Okay. All right, final question then, and we're going to kind of explore this a little bit further. One of the, in downtown areas, things like that, one of the great ways of creating residential space is taking old factories or old industrial lofts, properties, converting them into very stylish residential occupancies. The only problem with that is that they don't really look like your standard home or apartment where we've got the finished walls and you got the finished ceilings and you can hide all the piping and you can hide all the sprinklers behind concealer plates and things like that. So we've got this great, beautiful space, but nowhere to hide the sprinkler, with the requirement, by the way, that because it's residential, now it's required to have sprinklers. It's got this industrial type of, it may have an industrial type of system already in it, but now we've converted it from an occupancy that was being protected as an NFPA 13 system, but it was also light hazard, ordinary, whatever. And now it's got to turn into it's a residential occupancy, so now it needs residential type sprinklers. So I've got this beam ceiling, I've got all these other, other challenges. I want to maintain the integrity and kind of the nice look of it. But I've got, the only thing that's being offered really are these are kind of concealed sprinklers and sprinklers that are kind of hiding behind construction and stuff. The question is, does Viking offer a residential upright sprinkler that can protect, that could be used in a beam ceiling approach like this? If I've already got my piping in there, do I have something that can protect that space?
Yeah, we offer our VK 467 4.9 K factor residential upright sprinkler.
Sure.
And we were just talking about how listings kind of went away for residential sprinklers. Well, that's in most situations, but with this sprinkler, we have a special beam listing for the VK 467 because of what you just described. That's the type of area that the sprinkler would commonly be installed in.
So what we're looking at here then is an installation that goes underneath the beams?
That's correct. So you would install it, and you can have up to 14-inch deep beams with the sprinkler installed right below the beams.
Okay.
So as we can see here, we have the sprinkler installed in a beam sealing application, and you have the deflector a specified distance down below the beams,
Okay.
up to a 14-inch depth on the beams. So that's a very common application that you could see the sprinkler being installed in. And in this case, since it's going to be installed exposed below the beams, we're looking
Right.
at using steel piping for this situation
Right.
below the beams.
So the difference being here, I mean, still has to be 1626, right? I mean, we're still,
That's correct.
we're
Yep.
still testing it to that. But it's not a flat, smooth ceiling, it's not it's not your kind of clean, neat residential ceiling or wall that we're installing it. This is really a true beam ceiling that it's dropped down quite a ways below the ceiling line, and we're still meeting all of the requirements for spray pattern, for response time, for everything else that you find in 1626.
Yeah, definitely. And if you go to the technical data sheet, depending upon the size of the room where the beams are installed, there's different advantages for the calculations in which you can use for the calculations on the VK 467 in the beam sealing application.
Great.
So depending upon the size and the depth of the beams and the size of the room, so on, you have different requirements for how you would go about calculating it.
Great. Well, thanks for exploring residential sprinklers with us in this edition of Tech Talks. I'm Jim Lake with Shaun Kramer. Shaun, what's those technical, if you have any other questions, what's those technical services contacts?
You can call our toll-free number at 877-384-5464 or email us at techsvcs@vikingcorp.com.
Great, thanks a lot. So keep those questions coming. We'll help you in any way we can in tech services. We'll get you an immediate answer, and maybe even read yours on the Tech Talks. So thanks for joining us. We'll see you again on another Tech Talk edition.